Recording the solution to the final question for this test, question number 4. It's the KB problem. Okay, and really pay attention to this KB problem because it's probably going to be a KB on the real test. So KB, always going to do this first, is going to be equal to the concentration of the ammonium ions raised to the first power multiplied by the concentration of the hydroxide ions all over the concentration of the ammonia ion, or just the ammonium atom. Water doesn't count in an equilibrium expression. So NH3, NH4 plus OH minus, I'm doing my ice table, I, C, E, question mark, 0, 0, minus X, 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 question mark, X, X. Just like in the previous problem, the K problem that we did, we can assume that the X is essentially 0. Okay, so now let's go through and let's read the problem and look at what we have. They give us the KB of ammonia. So we have the KB. We know that's 1.8 times 10 to the minus fifth. Okay, and they say calculate the pH of a 0.5 molar solution of ammonia, which is NH3. So when you're trying to figure out where to plug something in, you go to your ice table. This 0.5 is not for NH4, not for OH, it's for ammonia, which is NH3. So that 0.5 is the question mark. And in relation to this table, it's the denominator. They do not give us any other pieces of information, so what I did is I put these X's up into here, and we ended up with the X squared value. Okay? So they say calculate the pH. Now it becomes important to look at your reaction and think about who is my route to the acid-base smiley face. It's not ammonia, it's not ammonium, it's OH minus. OH minus will be converted to POH, and POH will be converted to pH. The first thing we'll do is take the negative log of OH minus, and then we'll do 14 minus the POH to get to the pH. Okay? So all I have to do is solve for X. X is going to be equal to the OH minus concentration. Okay? And I know that POH equals negative log of X. And I know that 14 minus POH equals pH. So I'm going to go through and solve for X. X is going to be equal to the square root of 1.8 times 10 to the minus fifth multiplied by 0.5. And then what I'm going to do is take the negative log of my answer to that, and I'm going to get the POH. Okay, so this is going to be equal to the POH. And then I'm going to take 14 minus the POH, and I should end up with 11.48. So I want you guys to keep doing this until you end up with 11.48 for your answer. Okay, C, it says, NH3 is said to be soluble in water, while BH3 is not. Anytime you're talking about solubility in water and they give you Lewis structures, the concept you're going to be using is like dissolves like. Okay, so let's see who is like water. So water, which is H2O, has the Lewis structure O, H, 2 lone pairs. So water is polar with 2 H bonds. Okay, let's do NH3. NH3 is NHHH. So that is polar with 3 H bonds. And BH3 is equal to B, boom, boom. This is nonpolar with no H bonds. So subsequently, because like dissolves like, water, who is polar with 2 H bonds, is more like ammonia, who is polar with 3 H bonds, than BH3, who is nonpolar with no H bonds. In terms of the shape, this is trigonal pyramidal, with no pi bonds. This is trigonal planar with no pi bonds. Okay, guys? When you're doing these KB and Ka problems, the most important thing initially is to see that OH minus or H plus, when they're produced, those are your routes to the pH. In this case, you got to go to the POH and then to the pH. Okay? This is really what a KB problem is representative of, and a Ka is a little bit easier. Okay? Sometimes they're going to give you the pH and ask you to plug it back in. That could happen here also. Okay? Have a great day, guys. Thank you for being patient.